Yes, welcome everyone. And today we're coming to this environment where we, the engineers and people who are aspiring in technology, we shall be able to share about the views in many aspects. Let's say electrical engineers, mechanical, industrial, civil engineers, as well. Any person like is in the technological world, you are welcome. Yes. So my name is Emmanuel Kamukisha, and I'm by profession an electrical engineer. And here I am. I'll be giving this series about industrial automation, renewable energy, all those scopes, and also control panels here. So apparently I've been devising some videos, some lectures that I'll be giving you about PLC programming, and I'll be using a PLC from Delta Company. It's over here. It's in here. That's the PLC I will be using, and as well, it's of a model DVT14SS2 11R. So, in PLC programming, it's something that is not common to very many people, but it's very easy if you give it time and understanding. Apparently, in these videos, I'll be teaching you ladder programming to help you in automating and coding these PLCs. Ladder programming is something which is not so difficult, easy to be understandable. The syntax, of writing it is very simple. If you just give it time, I think you'll be getting to do what I have shown you in the introduction video. So, this is a PLC, this is the ladder programming, and then also anybody who is new here and you don't know things about truth tables. A truth table is something like this or that, and it's basically where we are trying to do Boolean algorithm, where you only have two things, on and off. When you have on and off, we are playing with switches. What will be your output? On and off. When you switch, let's on the wall, you have supplied it electricity, but you have not turned it on. That means it will be in zero position here. Then when you switch it on, it will be in a one position. So if you have two switches and you're collecting them differently, how will it be? How are we going to be getting the output? This one, I'm just going to drop it in a simulation. I'll simulate it. So here, guys, at least let me show you how the simulation is. The first one we connected it in O, and the second one is connected to give us the AND. You can see I have powered them, one with L, neutral, light, neutral, and then connected the two switches to get to know the results. As I told you, those ones which are connected in O, you only get an output, you fail to get an output when they are all off. But in AND, you only get an output when they are all on. Let's simulate and see. You can see when I press one switch in O, it's already on, another one is already on, like that. So, and in AND, it will be the contrary. You only get the output when everything is on, You see, it is not coming on, it's coming on, So basically, this is the Boolean thing I was trying to show you on the table. So you can go through the Boolean system and you know how it works. I'll simulate it for you guys, and then you see these two solutions whereby we have an O condition. If it is connected in an O, it's whereby you have switch 1, switch 2, and they are connected in parallel to the output. And if it is AND, you have switch 1 connected in series with switch 2, and you have the output. So what are you going to be having when you power the two, and what are the possible solutions? So if you don't know this, actually it is going to be hard for you to program in PLC, basically ladder programming. But if you're conversant with it, it will be so simple. Then we have to know about switches. Switches. What is a switch? A switch is like an electrical device that is used to complete the circuit. So we actually have two types of switches. There can be many, but basically in the form of operation in these PLCs, I'll urge you to know about the maintained and momentary switch. A momentary switch is a type of a switch whereby you just place it and it comes back on its own. You place it, it comes back on its own. Then we have a maintained switch. A maintain switch is something that you place and then it keeps there. So I'll give realistic examples. Talk of like a tube light switch in your home, maybe where you have to go and turn on the switch and it stays in that position. And then you think of a bell switch. A bell switch mostly on the doors, you just hit on it and then it produces the sound, but when you release it is out. So basically those are the two types of switches that are commonly used in this PLC programming that you really have to know. Then you talk about a sensor. What is a sensor? A sensor is an electrical device, or it may not necessarily be electrical, but it's a device that is used to convert energy, one form of energy, into accessible, gives a sense, accessible energy. Let's say you use a mechanical sensor and it's turning a mechanical parameter into, an electrical signal. It gives you an external signal that are going to scale, and then you come out to know, like, okay, if I have this kind of like lottery, whatever, like a tachometer, when it is revolving at these revolutions per minute, I'm going to be having this kind of voltage, and I can calibrate to know, the amount of speed at which this vehicle is moving. So basically that's the sensor. But in PLCs mostly, if you're gonna be using that, it's deeper into programming. As we progress, you'll be knowing. But I will add, we first appreciate the digital sensors, where it is only just going to sense there is a person that has passed or not, motion, that's one type of a sensor. We have very many sensors. Even a switch can be a sensor, just to detect on and off. So to ease whatever. Let's say we are talking on a conveyor belt, some object is traveling on a conveyor belt and switches over here, then the light sensor detects, obstruction of light. So it has to give a control to the motor. You stop, this fill, then after a timer, after the timing seconds of like 30, so all that. So basically, let's dive in. I show you simulations and everything, and by the end of this video, I'm glad that you'll be fair enough to produce your first PLC program. Story by story, we will be just getting some data from you, what you want us to be giving you, and I keep on researching and bringing more. So as I promised, we go far. This is the screen that I put to show you where the program is. It's on the right hand side, and then the HMD, that's the human machine interface, or the screen, is going to be on the left hand side. So apparently you can see the program, how it is written, and then the human, if you want the human machine interface to be also in the system, or you're going to always design, is always there. But apparently most of the control panels, they never have that, where someone can control the system remotely. It's only just the program that will be running. So I just wanted you to assimilate and appreciate the technology that we have, and consequently we shall be studying each and everything. As I promised you, so as we have agreed that before this video ends, you must be able to write a PLC program. I know some of you, it might be very hard for you if you have never engaged yourself in a PLC world or whatever. So I think I will just make it very, kind of medium, but as well, whenever you bring any kind of aggravations or you have any question, you just type it to me. I'll be giving you my contacts. You just type it to me. I will make sure that I will make a full video for any question that you actually have. So when we are going in the PLC world, to write like a PLC program, there are very many languages. Like we have sequential language, we have ladder language, and we have high-level programming languages. Right now, currently, actually, we have open source environments whereby you use like C to program. Because I would say most of the PLCs, they have been using ladder programming. So this is ladder programming. They call it ladder because of how it is. This one is like channel 1, network 1, and if I had any other command to write, I would put it here. So it will actually be moving like a ladder. And when it is performing the programming, or when you compile the program to generate the machine level code, it will be like following this pattern, like from top to bottom, So when you're programming, you have to understand some things. Like, it's from this side to this side, and it's from this side to this side. Then as well, this is like the positive rail, and then going the other end, the negative rail. Then as well, you have to understand that we have different types of elements you're seeing there. So this kind of an element signifies, it's something whereby I use to represent like a switch, like contact, and then this other side, this one represents an output. So this one could be a motor, could be a pump, could be a light, could be a heater, could be anything. And this one can be a switch. This is a start button, stop button, emergency button. And then you can see there is a space here, and here I put closing. It is not just like any mistake, it's something that represents normally open and normally closed. So this thing here and this thing here, you really have to take your time and assimilate it in your mind, so as you can really get to run programming in ladder very easily. It is not something that is. So I wanted, just before we go any further, you first see how the program looks like. This is how you program in Delta. So you can see the start button, the stop button, and the emergency button. Then again, you can see the output. That is the motor output and the green light. So ahead, I'm going to explain everything. Hard, it is something that is simple if you give it time. Like normally open, normally close, there are these things that are normally in relays, in PLC programming, and it is something that when you understand, I'm just going to make you understand here, like when it is normally open, and this is positive, honestly, if it is normally open, let's assume I have a wire, this is a wire, and then I break in the middle here, it becomes normally open. So if I was having positive here, and I was having an element here to receive power, it cannot receive power because now it is normally open. So now in PLC, if I have a switch, a start switch, and I want it to be placed, and immediately the bulb receives power, that means it has to be open in the first place. So a normally open switch, it does not conduct, or if you do a continuity test, it does not show like it is closed, like it flows in power. So immediately here you have to understand, like when you have to use normal open is when you don't want anything to run this any side further, but it has to stop. Not until I place the switch. But gladly, if you don't understand it from here, from the board, you're going to understand it from the programs that I'm going to be running. And they are very physical, and then they are, even the PLC itself, as it's going to be practical, I think you cannot fail to understand it. Then a normally closed, a stop switch, I connect it in a way that it is connected in a normally closed position, because I'll give an example. I'll not give an example, but I'll give you the reason as why it is connected in normally closed. So that could be something that you could share with me if you know it, or if you don't know it, I'll just share it with you later on. So now let's understand how this program works. I have 3 switches, buttons, and let's presume they are maintained buttons. Let's presume they are maintained buttons. In this case, I could have written another program if we were having a push buttons. I will actually show it to you. I will run the 2. In the next video, I will do with momentary switches. Those ones are the ones which are not maintained. So here, if I place this switch, it becomes normally, it closes now. When I place the start switch, it closes. And when it closes, that means current is going to flow through this switch. It is going to come here. It finds the stop button when it is in a normally closed condition. So current flows. When it reaches here, this emergency stop button is also connected in a normally closed way. So our output is going to get power. As well, the output, the motor is connected in parallel with the indicator. So these all are going to be getting power. So your pump will run, or your motor will run, as well as the indicator. Let's say it is a green light. Let's say it is green.